Hello everyone. This Math Olympiad question looks incredibly simple, but it completely breaks the standard algebra tools if we try to use the direct substitution method. Now, instead of us substituting, we are going to be exploiting the perfect symmetry of these two equations. A is our first equation, which says a squared minus b equals 133, and a is our second equation, which says b squared minus a equals 133. And here is the question before, which says a and b equals what? Instead of substituting, we are going to be exploiting the perfect symmetry of these two equations. Now let's subtract equation 2 from equation 1. Here is our equation 2 and here is our equation 1. So by the time we subtract, we are going to be getting this, open bracket, a squared minus b squared minus a equals 133 minus 133. Now we have what? A squared minus b squared plus a minus b equals 0. Now let's factor the difference of squares, a squared minus b squared, which will give us what? A minus b multiplied by a plus b plus a minus b equals 0. By factoring the difference of squares, we can pull out a common term of a minus y, leaving us with a minus b multiplied by a plus b plus 1 equals 0. Now, this gives us two cases. Case 1 is what? A minus b equals 0. That is, a minus b equals 0. So by the time we substitute this, we are going to be getting what? A equals b. Now, the second case is what? A plus b plus 1 equals 0. So this is our first case and this is our second case. A plus b plus 1 equals 0 will give us what? A plus b equals minus 1. So for case 1, we have this, and for case 2, we have this. Now let's solve case 1, which says, case 1 says a equals b. If a equals b in case 1, then let's substitute a into the first equation. Our first equation says a squared minus b equals 133. Now let's substitute, which will give us what? A squared minus b minus 133 equals 0. Using the quadratic formula, which says a equals minus b plus or minus square root of b squared minus 4ac divided by 2a. So we have our a equals 1 plus or minus square root of 1 minus 4 times 1 times minus 133 divided by 2 times 1. So our a now becomes what? 1 plus or minus square root of 1 minus 4 times 1 will give us 4 into bracket of minus 133 divided by 2 times 1 will give us 2. Our a becomes 1 plus or minus square root of 1 minus times minus will give us plus. 4 times 133 will give us 532 divided by 2. 1 plus 532 will give us 533. So we have our A equals 1 plus or minus square root of 533 divided by 2. Since case 1 says A equals B, this yields two pair solutions. That is, A or B will give us what? 1 plus square root of 533 divided by 2 in two ways. So we have this and also this. 1 plus square root of 533 divided by 2. We are having this in two ways because A equals B and this is two pair solutions. Now let's move to case 2. Now let's solve case 2. Case 2 says A plus B equals minus 1. A plus B can either be minus 1 or B can be minus 1 minus A. Now let's add the original two equations together to find AB. Equation 1 says A square minus B equals 133. Equation B says B square minus A equals 133. Now let's add the two equations together. A square minus B plus B square minus A equals 133 plus 133. So A square plus B square minus into bracket A plus B will give us 266. We know that A square plus B square will give us A plus B square minus 2AB. Now let's substitute. That is A plus B square minus 2AB minus into bracket A plus B equals 266. Let's substitute A plus B equals minus 1 in our case 2, which will give us what? Minus 1 square minus 2AB minus 1 equals 266. Minus 1 square will give us, or minus times minus plus 1 times 1 will give us 1. So we have 1 minus 2AB minus times minus will give us plus 1 equals 266. 1 plus 1 will give us 2. So we have 2 minus 2AB equals 266. Now let's collect like times. Minus 2AB equals 266 minus 2. So minus 2AB will give us 264. Now let's divide both sides by minus 2. So we have this by minus 2, this by minus 2. Minus 2 cancel minus 2. Minus 2 in 264 will give us what? Minus 132. Now we have a classic system which says A plus B equals minus 1. We got that from case 2. Then AB equals minus 132. That was after we've solved our case 2. So these two numbers are the roots of the quadratic equation t squared plus t minus 132 equals 0. Now let's factor this, which will give us what? Open bracket t plus 12 times t minus 11 equals 0. That means our t can either be minus 12, because by the time we bring this out, we have t plus 12 equals 0, which will give us t equals minus 12. And let's bring out this t minus 11 equals 0, which will give us what? T equals 11. So our AB equals 11 and minus 12, or minus 12 and 11. So you can either swap, you can either say A is 11, B is minus 12, or A is minus 12 and B is 11. At the end of the day, you are still going to get the correct answer. Thank you for watching.